Hello everyone and welcome to the channel. I'm Emmanuel, I'm an airline pilot and a member of the PMDG 777 beta team. Welcome to the tutorial on our initial descent in the PMDG Boeing 777. If you're interested in an even more complete and written version of this tutorial, have a look at my 777 ebook, which you can find in the video description below. And now let's go right into the tutorial. We're approaching our top of descent. We currently have some 17 nautical miles left, and you can see that the reset MCP altitude message has been triggered. This serves as a reminder that we need to set the MCP altitude down in order to start our descent automatically. If you don't do that, the airplane is just going to maintain altitude and you will have to apply some correction manually. So when the message shows, that's normally a good indicator to start asking for your descent clearance. When descent clearance is received, let's say we go all the way down to flight level 140 today. When descent clearance is received, you set the MCP altitude down, and now there are two different options. If you can start your descent when ready, as per ATC clearance, then you simply leave the airplane like that. VNAV path mode is active, and so as long as VNAV path is active, the airplane is automatically going to initiate the descent when you overfly the top of descent. If ATC wants you to descend early, you can press the altitude knob in, and this is automatically going to initiate a shallow descent at about 1,250 feet a minute. The way this works is the airplane automatically starts to reduce thrust to a previously defined level, and at that level, or rather that thrust level, is designed so that you achieve approximately 1,200 feet a minute rate of descent. However, as actual weather conditions can vary from the ideal weather conditions for which the thrust is calculated, the rate of descent that you actually achieve may be a little bit more or a little bit less than the target descent. You can see the airplane lost a bit of speed now, which it is picking up again. Once we're back on speed, the descent rate will come back again, and that way the rate of descent is going to vary slightly in favor of maintaining a constant engine thrust and therefore maintaining greater passenger comfort. Now, since we are on the so-called early descent right now, the aircraft is going to intercept the profile from below. Once the profile starts coming down at the predicted optimum top of descent, which is basically now, you can see the profile is getting closer to us already. Eventually we are going to intercept this profile and continue with an idle thrust descent. Now, initially the 777 is going to maintain Mach number, and later it is going to convert onto the airspeed that you have entered on the Econ descent page. So once the target speed is reached, so 283 knots in this case, you will see that it switches over here from a constant Mach descent to a constant indicated airspeed descent. The VNAV profile is coming in, and as soon as this is approaching, the plane is going to change from VNAV speed to VNAV path and will retard the thrust levers all the way to idle, which we can see right now. So let us take a moment to discuss how the VNAV path is actually constructed. Basically, path construction starts at the end of descent point, and the end of descent point is usually located at the runway. Now, from there, the path is constructed backwards, so first you got the 3-degree descent till the Fox, then you got the 3,000 foot restriction, so you would have a constant angle between those two, and then it just calculates backwards for all these restrictions over here. And basically, ignoring all the restrictions, our current descent path starts right up here at the flight level 140 restriction at Zurich. And above that, it's calculating an idle path descent based on the amount of drag that the plane is expected to have at the airspeed that you have programmed as part of the Econ speed. Now, once the actual descent is started, VNAV is going to favor maintaining the path over maintaining the speed, and it will accept a certain deviation from the target speed. Now, that certain deviation can be changed by the airline. Most operators are using 15 knots as maximum permissible deviation. When those 15 knots are reached, VNAV has a little compensation feature where it tries to pitch up a tiny bit to reduce the airspeed and accepts a deviation of up to 150 feet from the vertical path. And yes, this stuff is all modeled in the PMDG 777. And if that fails, if it's not able to maintain the speed, or if it loses the path, then it's going to revert into VNAV speed and will then simply maintain the airspeed that has been targeted over here. Now, if a situation like that happens, you've got two possibilities of what you can do. You can either increase the target speed so that you get a steeper descent profile, or you can use the speed brake. Now, as someone who flew short haul for 5 years on Boeing aircraft, I would of course increase the target speed because that reduces total flight time and therefore would reduce the overall cost of the flight, since you have less time that the engines are running and therefore less fuel usage. However, many long-haul pilots just don't bother with that kind of optimization anymore, because we have to face it, you just flew a night flight, you're probably tired, and if you then start to play with your speeds and increase the speed, yes, all that good stuff works perfectly fine on short haul, and it would work on a 777 as well, but many long-haul pilots would simply use the speed brake while maintaining the present speed in order to catch the path again. The 777 has a very, very efficient speed brake. To give you an idea of what the speed brake can do, there is a little table in the flight crew training manual of the 777. So let's have a look at a couple of default values in the descent. So if the plane descends at a speed of Mach 0.84 or 310 knots, when passing flight level 200, we expect approximately 2,200 feet per minute rate of descent in idle thrust. Now, if the speed brake is used, those 2,200 feet a minute increase to 5,300 feet a minute. So that is a super effective speed brake. At 250 knots, in clean configuration, the airplane normally descends at 1,400 feet a minute, and the speed brake can increase that rate of descent to 3,300 feet a minute. Finally, at the flaps up maneuver speed, so at the minimum clean speed, normally you have a rate of descent of 1,000 feet per minute, but the speed brakes can increase that to 3,300 feet per minute. So you can see there is a huge potential to kill altitude by using the speed brakes in the Boeing 777. Now, the pilot should normally follow the descent path with a couple of mental calculations. We will talk about those in a few moments, but let's first talk about the seatbelt sign. So, different operators use different techniques. One 777 operator normally turns on the fasten seatbelt sign in the descent when passing approximately flight level 250 or the top of descent, depending on whichever is later. That operator flies both short haul and long haul in his 777s. So passing flight level 250, we can turn the seatbelt sign on. Now, other operators might employ different procedures. So for example, one operator that only flies long-haul flights always turns the seatbelt sign on half an hour before landing. Of course, if turbulence is expected, that would also be a reason to turn the seatbelt sign on early, but in that case you should notify your cabin crew of the time remaining to landing in order to avoid any confusion. And now let's get back into energy management and vertical planning. So generally, you should follow along whatever your VNAV does. Never let the airplane fly something that you don't want it to fly or that you're unsure of what it is currently doing. So, let's do an easy example. At Zurich, we need to be in flight level 140. Now, by default, we need 3 nautical miles to lose 1,000 feet altitude. So we are now in flight level 220, let's say, so we need to lose 8,000 feet. That means 8 times 3. So that is going to result in 24 nautical miles in order to lose that altitude. So when we're passing 22,000, we should be about 24 miles from Zurich. Now, since we have a tailwind, we take a little bit longer distance, and in general, you can see that this cross-check works rather fine. We're around about at 30 miles over here, so tiny difference, but the general gross error check is correct. You also have the VNAV descent page on which you can see what vertical speed you need for your descent. So if we look at this, then we can see there's Zurich at flight level 140 in here. And the plane tells us that in order to meet that restriction, it needs 2,000 feet a minute rate of descent. So the airplane as you can see, does about 2000 feet a minute. So that serves as another cross-check that we are on path for the descent. Now the 777 has another very cool feature that other 737s like the 737 does not have. So that's the off-path descent. By default, the off-path descent is set to the runway waypoint at the landing field elevation. If you turn the off-path descent display on, you are seeing two circles. Now the outer circle represents an idle path descent without any drag devices straight into the runway. So from the present position straight to the runway. It ignores the route that we have in the FMC. The inner ring, the white one, represents the descent distance you would need with the speed brake. Now in our current situation, being halfway between the blue and the white ring, we would need partial speed brake in order to lose that altitude. In that situation, it is recommended to use the speed brake until the blue ring equals your position, and then you can retract the speed brake and resume your normal idle path descent. However, when using this feature, be aware that the landing runway, or that the target waypoint, is always taken as a direct distance. So you can see over here, distance to go 55 miles. That's direct from here to there. It does not take into account that we have to fly around the airport and come back for landing. So just be sure to know how you're using this feature. Let's have a look at an example. If we enter Zurich in there, like this, it automatically takes over the restriction from the flight plan, and you can see that now it's calculated our descent rings here again, and you can see that we're exactly on the blue ring. So we are exactly on the clean path profile to this waypoint and this altitude. Can remove that again, and now the runway is re-entered. You can enter any waypoint and altitude combination on the off-path descent. So this provides a really good feature for you to control your descent and cross-check your descent distances. Of course, we got to be aware when we can use it. So right now, since we still have to fly around the airport and come back, there is not really any sense in using this. So we can switch the display off again. And that's the off-path descent feature in the Boeing 777. Really cool feature if you know how to use it. So we can continue our descent down to 7,000 feet, which is going to be our next restriction after Zurich. Now, if ATC clears you to descend to a flight level that is below a constraint, technically speaking, you would first dial in the constraint, and once you are 2.5 miles prior to the waypoint in VNAV, then you can dial in the next lower altitude. In practical terms though, many 777 pilots would simply go ahead and dial in the ATC cleared altitude straight away if VNAV has the vertical restriction in its flight path. We've passed Zurich, and now our VNAV has changed the mode. It is no longer descending in an idle path profile, but now it's drawn a constant rate of descent, a so-called geometric descent profile, from Zurich at level 140 to the next restriction, which is Oakham at 7,000 feet. So now we're descending at a constant rate of descent down to that profile. There is one big gotcha in the 777 with those profiles, and that is that these profiles are based on a constant rate of descent and they do not take deceleration segments into account. In other words, when we approach flight level 100, the airplane is not going to automatically decelerate, but much rather the airplane is going to simply set the speed target down, and if it cannot slow down, it will revert to VNAV speed and thereby lose the path. That's a gotcha in the 777, and you gotta counter it using speed brakes. This is not exactly a very efficient maneuver. As you can see, we are currently using thrust in order to descend, but that's how the airplane works. A final word here on anti-ice usage. Just like in the climb tutorial, anti-icing in the descent is fully automatic, and you can hear the sirens going off. So the standard Boeing or Airbus pilot does not have to touch it. All you gotta do is check that it comes on if you see the airplane icing up. Well, and that basically concludes our descent tutorial. I hope that you learned something today, and if you did, be sure to let me know in the comments below. I'm very much looking forward to your feedback. As always, be sure to like, comment and subscribe, and if you really love what I'm doing, I would appreciate a small donation through the Buy Me Coffee link in the video description below. If you're interested in a written version of this tutorial, check out my Ultimate 777 Guide ebook, more on that in the video description below. Thank you very much for watching, and then I see you all again on the next one.